Good morning, ladies and gentlemen. My name is Sukatiman. I am with Idanugroho Saputro and Ma'ruf Mahmudi from Universitas 11 Maret. Will presentation our study with the title The Influence of Replacement of Fine Aggregate with Slug Waste on Content Width and Compressive Strength in Paving Block. Introduction. Road construction is increasing with time to time based on the Central Bureau of Statistic data in Central Java province. In 2019, reached 22,767 kilometers. On the other hand, growth in the last 3 decades, the industrial sector has significant increase. One of them is the metal casting industry. The metal casting industry causes negatively impact in environmental pollution because produce slag waste from the metal casting process. Slag waste result from the metal burning process, heated at temperature 1,600 degrees Celsius and is in the form of liquid which will crystallize over time. Slag waste has an irregular shape, sharp, solid like a stone, shiny black color, and various shape. This slag usually has a chemical composition such as silica, alumina, ferrous oxides, magnesia, and alkalis. The high silica content in the slag waste is expected to increase the hydration process between cement and fine aggregate form a maximum interface or strength. From this explanation, it is necessary to research the use of slag waste as an alternative material to replace fine aggregate with replacement variation of 0%, 45%, 50%, 55%, 60%, and 65% of the paving block volume. Based on the research background, the objective of the research is 1. To determine the effect of slag as fine aggregate on the paving block's content, width, and compressive strength. Second, to determine the effect of slag as fine aggregate with replacement variation of 0%, 45%, 50%, 55%, 60%, and 65% of the sand volume on the paving block's compressive strength. To determine the effect of slag as fine aggregate with replacement variation of the selected of the sand volume on the paving block content width. This is an example of slag waste picture, and this is dimension of Batako. Research methodology. This research was carried out in various places. Slag waste have from CV Salwa Logam, Jawa waste in Ceper, Klaten. Testing of fine aggregate preparation of make design and testing the paving block content width and compressive strength were conducted at the Concrete Laboratory, Building Engineering Education Faculty of Teacher Training and Education, UNS Surakarta. This research is experimental quantitative use linear regression to analyze data. Testing of the paving block content weight and compressive strength was based on SNI 030691 1996. The data analysis technique employed was the uniformity analysis of variation according to the SNE 036815 2002 standard. The result, this is the graphic of compressive strength, where the vertical coordinate show the content weight in kilogram and meter cubic, and horizontal coordinate is SLAG with variation in percent. The table above show an increase in content weight at each additional variation of the SLAG replacement. The increase in the paving block content weight caused by several factors, such as the material type and the material composition used. With a large enough specific gravity of the SLAG is 2.86 gram per centimeter cubic. The increase in the percentage of SLAG substitute material was followed by increasing the paving block content weight. And this is the paving block compressive strength testing. Vertical coordinate is compressive strength on a megapascal, and horizontal coordinate SLAG variation on percent. And this is the table of uniformity analysis of variation based on SNE, standard control. Conclusion, the condition that could be obtained from the data analysis result and discussion in this study are: 1. The effect of the SLAG variation replacement on paving block, increase content weight and decrease compressive strength. 2. Paving block with SLAG replacement variation of 0%, 45%, 50%, 55%, and 60%. Also, 65% could affect the paving block compressive strength by 86.48%. The percentage of SLAG replacement reducing the maximum compressive strength in paving block is 50% paving block weight, with a compressive strength value of 40 megapascal included in the quality category. I think that is my presentation. Thank you.